Kelvin Wave, now on WeatherMedic's Weather Buff. I am Jack Knack, the Weather Medic, the Doctor of Weather, with a discussion on Kelvin waves. The waves that most of us are familiar with are the waves at the beach, waves that endlessly curl and crash on the shore, but the ocean and atmosphere also have what are called planetary waves. These are waves of massive and immense scale. Kelvin waves are a kind of planetary wave. Unlike the waves at the beach, Kelvin waves do not curl over and then crash. They are more like the waves in your bathtub, which slowly slosh around. They don't break, but they still have broad peaks and valleys that change the depth of the water. The ocean equivalent is sea surface height. The Kelvin waves that are relevant to ENSO and this video only move eastward and along the equator. Like all planetary waves, the geographic extent of an equatorial Kelvin wave is huge, often stretching over much of the Pacific Ocean, thousands of miles. Equatorial Kelvin waves have two phases, which can lead to very different changes in subsurface and sea surface temperatures in the eastern tropical Pacific. What you're looking at here in this diagram is a downwelling phase of the Kelvin wave. You have here surface depth in meters along the y-axis, or you have depth of feet in meters here. And also you have the temperature scale is the colors here on the bottom. And also what we have is the time here is on the left-hand side of dates and time. This is going from February all the way to April of this year of 2023. And what's happening is with this downwelling phase of the Kelvin wave, that normally winds blow from east to west across the tropical Pacific, which piles the warm water in the western Pacific. So the air is moving normally at the surface this way. So you have that piled up, that warm water piled up on this side of the Pacific over here. Well, what happens is that a weakening of the wind starts. The surface layer, as this weakening diminishes, this surface layer that's piled up on this side, it starts cascading eastward. And that's what we're looking at here. We're looking at this cascading eastward. The thick, warm layer sloshes east, pulling down the thermocline as it goes. Thus, we call this a downwelling wave. The thermocline is actually the boundary between the warmer, near-surface mixed layer and the colder, deeper water. Scientists use the subsurface temperature of about 20 degrees Celsius or 68 degrees Fahrenheit to define the boundary of the thermocline. Around the 20 degrees Celsius or 68 degree Fahrenheit layer, ocean temperatures change rapidly, a strong temperature gradient. On average, the thermocline is found at a deeper depth in the western Pacific and is closer to the surface in the eastern Pacific. So that's what you're seeing here. See how this wave is going like this? Because that's kind of how the thermocline is going. Because of this downward push as the wave travels eastward, it is harder for the colder, deeper water to affect the surface, so near-surface temperatures are often above average. This will often, not always, warm the surface temperatures and plant the seeds for an El Nino. Well, the other phase is an upwelling phase. Sometimes after the downwelling part of the wave goes by, we sometimes, but not always, see a rebound or upwelling where there was once downwelling here. The colder water at depth upwells and the thermocline becomes closer to the surface. We often will see below average temperatures near or at the surface. The question is, are we going to have an upwelling phase following the downwelling phase? If you would like to see more of these posts or would like to say thanks for this one, please consider becoming a supporter. To support the channel, go to patreon.com/WX Medic. This is Jack Knack, the weather medic, the doctor of weather. Thanks for making Weather Buff a part of your day. Good day, everyone.
Weather buff.